Okay, this is our first question. 1 plus y is a dx plus x into z minus x dy plus minus 1 plus xy dz is equal to 0. It's asked to check whether the equation, this given equation is integrable and solved by Nathani's method. We know how we can find whether given Paffin differential equation is integrable. We have to construct the vector capital X, which involves as coordinates p, q and r. Have to find curl x and take the dot product x dot curl x. If that's equal to 0, then the given Paffin differential equation is integrable. Now it's specifically asked us to solve by Nathani's method. So let's try how Nathani's method goes. In Nathani's method, the first step is to decide which variable you are going to take into consideration to be a constant. You have 3 variables and you can choose as you wish, but the only thing is always keep in mind that whichever variable you are going to treat, the remaining Paffin differential equation should be easily integrable. So if you look over here, if I am taking z to be a constant, then dz will be equal to 0. The remaining Paffin differential equation will be 1 plus, let me cover this, 1 plus y is a dx plus x into z minus x dy equal to 0. If you are going to integrate that, it is a constant, so there's no problem over there, but over dx, underneath dx, it will we'll get a term x into z minus x. So we'll have to use partial fractions and do it. It's no problem. It's a little bit complicated. Just thing is you have to use the partial fractions and then integrate. Okay. At the same time, if you are going to consider y as a constant, then the second term is going to be gone. The remaining terms are easily integrable in terms of x and z, because here you will have just 1 plus some constant into z dx, and here you will have 1 plus x into some constant into dz is equal to 0. It's easily integrable. So what I am going to do is, I am going to take y to be a constant and do the rest. So my y is a constant, so dy will be equal to 0. The remaining Paffin differential equation will be 1 plus yz dx minus 1 plus xy dz is equal to 0. Now this is easily variable separable. So dx by, I am taking the denominator over here, dx by 1 plus xy is equal to dz by 1 plus yz. Okay. Now it's just it's easily integrable. So this will give me log of 1 plus xy 1 by y, log of 1 plus xy, and the next term would be, this is equal to 1 by y log of 1 plus yz. Okay, y gets cancelled from both sides, these two y's will be gone. I need a constant, let me say this as c1. Okay, so c1 into y. Okay, this will be the answer, c1 into y. Now I am taking logarithm to this side, so I will get 1 plus xy by 1 plus yz. I am taking logarithm to this side and taking the exponentials. We will get e raised to c1y. Let me consider this as a function of y. Okay, this y, this c1 can be a function of y, because we had already said while we are explaining the Nathani's procedure, the c1, since y is a constant, c1 can be a function of y. So this whole thing I am substituting as f of y, that's some arbitrary function of y. So this is my first equation. Let me name this as 1. I am ready with my first equation. For the second equation, what we have to do is, we have to consider, let me name this as 2. This is my first one. We have to consider take into consideration the remaining 2 variables, that is, we are left with x and z, because we had treated y as a constant. We are left with x and z. Either of the one should go into a constant. While we are explaining the procedure, we had given is it at least one variable should be treated as a constant. We have given the value alpha in particular. It's always better if you can give z is equal to or x is equal to 0. That will be much better. But whenever you are choosing the variable to be 0, always take a look at the denominators. If denominator is going to be infinity, then denominator is going to be 0, then definitely we cannot choose the value 0. Here in this case, we have to check again which one we should choose. Say for example, if I am choosing x is equal to 0, when x is equal to, when we are choosing x is equal to 0, this term will be gone, first one, because dx is equal to 0. So we will be left with this and this. What happens when x is equal to 0? In the first term, this whole thing will be equal to 0 and will be left with dz alone. That cannot happen. So we are not choosing x, we are choosing z to be equal to 0. Z is equal to 0 will give me dz is equal to 0. So the first equation again reduces to a Pfaffian differential equation of two variables, namely x and y. So this will be x plus y z is equal to 0 will give me dx plus, sorry again, minus x square dy is equal to 0. This is my Pfaffian differential equation of two variables. This can be easily integrated. This is variable separable. Dx by x square is equal to dy. That will be minus 1 by x is equal to y plus c2. Okay, I've got minus 1 by x, hope it is right, minus 1 by x is equal to y plus c2. Okay, from here we'll get x to be equal to, let me say 1 by x is equal to, 1 by x is equal to minus y minus c2. Okay, I am giving c minus c2 to be another constant, say c3 minus y. So x will be equal to 1 by c3 minus y. That will be my x. X is equal to minus 1 by 1 by c3 minus y. Now what remains is, that's x over here for you. This is my third equation. I have x. Now what remains is, I have to put z is equal to 0 in equation number 2. This was our first solution. This is our second solution for the same Pfaffian differential equation 1. So the remaining step would be to put z is equal to 0 over here in 2 and try and eliminate the remaining variable which was untouched till now, that is x. We have to put z is equal to 0 in equation number 2, and using 3 and 2 we have to eliminate x. Okay, let's try that. This is my second and third equations. 1 plus xy by 1 plus yz is equal to f of y, and x is equal to 1 by c3 minus y. I'll put z is equal to 0 in equation number 2 to get 1 plus xy by 1 plus y is equal to f of y. This is my equation number 4. Now what I have to do is, I have to eliminate the third variable, that is the untouched variable. Here the untouched variable is x. From 3 and 4 I have to eliminate x. Here we have got the value for x. I am going to substitute over here to get the value of x. This will be equal to 1 plus xy is equal to f of y into 1 plus y. Okay, my x would be sorry. This will be 1 plus xy is equal to f of y, because when z is equal to 0, my denominator will be gone. Okay, so 1 plus xy is equal to f of y. Now from there I am substituting for x. I am eliminating x from this equation. So that will be y by c3 minus y is equal to f of y. If you take the LCM and do the math, you will get c3 by c3 minus y is equal to f of y. Now I am having a value for f of y, which I am going to substitute in equation number 2 to get the final answer. Substituting in equation number 2, we'll have 1 plus xy by 1 plus yz is equal to c3 by c3 minus y. Now if it's okay if you can just leave it over here, no problem. Your final solution is actually reached, but you can just make the answer little less complex. Let me just cross multiply and see what happens. C3 minus c3xy square is equal to c3 plus c3yz. Okay, c3 goes from both sides. Now I hope, no, I have lost it over here, sorry. Let me try once again. C3 minus C3 minus y plus C3xy minus xy square is equal to C3 plus C3y, I said. C3 gets cancelled from both sides. I'm taking C3 to this side over here. C3 into y, C3y is common, x minus z is equal to xy square plus y, which is equal to xy plus 1. Okay, so I am having a y over here in both sides. Let me cancel those. What remains is C3 is equal to xy plus 1 by x minus z. So this will be our final answer.